So in this lecture, I will discuss some more problems so that you can do majority of the problems that are given either in the semester end exams or in the UPSC engineering services or in GATE, especially related to infiltration indices. So keeping that as in mind, let us work some more problems. But kindly note that whatever problems that today we are doing are also useful when we are studying the next runoff unit. There also they are useful, right? Keeping that in mind, please note that these problems are very, very important in unit 2, and keeping that in mind, concentrate on each of those problems and where the real crux of the problem is there. Please look into that and then let us work into each of the problems. Now I will take the problem, the rates of rainfall. Please remember here it is rate of rainfall. Please note that rates of rainfall for the successive time interval 30 minutes of a storm. What is the total duration of the storm? 3 hours. Or he has given the ordinates 1.6, 3.6 like that and so on, 1.0 centimeter per hour. The moment he has given rate of rainfall, naturally it is to be with respect to time. So centimeters per hour. The corresponding surface runoff, he has taken it as 3.6. So because of that 3-hour storm, right, that intensity had changed, varying from 1.6 to 3.6 to 5.6 to 1.0 centimeter per hour. But out of the entire storm, what is the final runoff? That means the water that flow on the surface of the ground. How much it is? That is 3.6 centimeters. In such a case, what is phi index? That is your question basically. If that is the case, now what is the data given? So, you know, storm intensity is known, estimated surface runoff. Now, phi index, what is the equation? Phi index is equal to effective rainfall, fine, minus runoff divided by effective time duration. So, when you are calculating the effective rainfall, it is the only time when there is runoff. Suppose rainfall occurs. If the entire rainfall goes into the ground as infiltration, as loss, then naturally that is not effective rainfall. Effective rainfall means the time during which the rainfall value is always such that it is more than the losses and it is always contributing to surface runoff. So the rainfall values which are contributing to the runoff, they only are considered when you are calculating phi index, right? Kindly note that. That's why the effective rainfall contributing to runoff. If the rainfall is not contributing to the runoff, that is not counted at all, right? That you should be very clear, right? And the duration also, the time during which the rainfall is not contributing to the runoff, that time is also not considered. This is effective rainfall, effective time duration. That you should really show it in your mind, right? Come next. Now, if you see, I do not have anything because how to know about it? How to know whether that, for example, that rainfall is contributing to runoff or not? How can I know it initially? So here with this data, what is given, I do not know that at all. So what I have done, first I estimated what is the total rainfall. Total rainfall means all I have taken, but it is 30-minute period. Now intensity is taken. So per hour how much? It is 30 by 60. So I have calculated what is the total rainfall. So during the 3-hour storm, what is the rainfall value I calculated? So that rainfall minus basically the runoff divided by the total duration I have put it. But is it represents phi index? Definitely no. Phi index means actually this has to be effective rainfall, this has to be effective duration. But now what I have taken? Total rainfall I have taken, total duration I have taken. So that is why I have put it as approximate phi index. But one more point I want to tell you here. This represents, if suppose the other losses, initial losses are 0, this particular 8.1 minus 3.6 by 3, it represents the W index, but not phi index. So in such a case, what we will do is we will try to calculate W index first, right? So that is why I wrote approximate phi index. You also can write it as approximate phi index in bracket W index. I got it as 1.5 centimeter per hour, right? Now I assume 1.5 centimeter per hour. So if 1.5 centimeter per hour, if I take it, now I will represent it on the figure for your understanding. So if I take it, this is the time and this is the rainfall intensity. For example, so this is 0, 30, 60, 90, 120, 150, 180, right? 180, 210, then 240, like that it will go on, right? 30 minutes, 30 minutes. So now if I take it, first 30 minutes, how much actually here if I take it? 1, 2, 3, 4, 5, 6 maximum, right? So now first 30 minutes, how much it is? 1.6. So this is like this. Second is how much? 3.6. Third is how much actually? Again 3.6. Fourth is how much actually? 2.8. Fifth is how much? 2.2. Next is how much? 2.2. Next is how much? 1.0. Over. So now, what is the phi index value? Approximate value, you got it as 1.5. So I draw a line. This may not be correct value, but I draw a line. So this represents how much? 1.5 centimeter per hour. So now below this line, whatever is there, all this is infiltration, and this is contributes to phi index. Above this contributes to runoff. So now how many time durations are contributing to runoff? The first one a little bit, second one, third one, fourth one, fifth one, sixth one a little bit. So one is not contributing to it at all, the last one. So total duration is, instead of 3 hours, means 180 minutes. Out of 180 minutes, how much is taking it? 30 minutes it is not there at all. Runoff is not there here. So only how much is the total time? 150 minutes. 150 minutes means how much it is? 2 hours 45 minutes. Keep that in mind. Now assuming this. So normally if I call it as W index, the phi index value will be always greater than W index. Please note that. So if that, then what I have taken is, so if taking this itself 1.5, now I have put 8.1 minus R divided by, what is the effective duration? The last half an hour is gone case. 1 is not counted at all. So remaining is 2.5 hours. 2.5 hours means if I put it, how much runoff I got? 4.35. But what is the given runoff? 3.6. That means 1.5 is not correct at all. Understood? So that's why what I have done, I have taken 1.6. And knowing very well that 1.5 you need not even try. I am telling right now. What you can do, 1.5 you can take it as W index. So now go for higher value, 1.6. So I have gone for 1.6. If I have gone for 1.6, naturally the first one is 0. The last one is there, not there. So 2 are gone. So remaining are how many? Out of 3 hours, it's only 2 hours. So calculate that 1.6. It is total is how much? Only 2 hours. If you take it, it is 6.8. Why not 8.1? In that 8.1, the first one is 1.6 is removed, last one is removed. So remaining is how much? 6.8 minus R by how much is the total effective duration? Only 2 hours. Why only 2 hours? The first half an hour is 1.6. Contribution to runoff is 0. The last is 1 centimeter. Contribution to runoff is equal to 0. Why? Because You have assumed phi index as 1.6. So put it, now you are getting R is equal to 3.6. That means your phi index 1.6 is right. So kindly remember that if only rainfall intensity is given and you are also given only runoff, in such a case phi index you want to estimate, there is no direct way of estimating phi index. You have to do first try W index, and from there trial and error you have to do it and then get the answer. But while doing trial and error also, please be cautious that you need to remember always, I must write effective rainfall, I must write effective duration. So that if it is there in your mind, you can do it very fast. So this is one of the problems. Like that, let us take one more problem. So in this problem, if you see it, the average rainfall over 45 hectares of watershed for a particular storm was as follows. The volume of runoff from this storm was determined as 2.25 hectare meters. Determine W index and phi index. So time versus rainfall. This is not intensity. Please note, time versus rainfall only given. What is the total rainfall? So it is 1 hour duration. So that's why I have put 1 hour. If it is 30 minutes duration, 30 by 60 I will put it. It is 15 minutes duration, 15 by 60 I will put it. So converting it into hours, because so this is centimeters. So it is 1 hour duration only. So final answer is total is 9.25 centimeters. Then what is the total runoff actually? Runoff is equal to, how can you get it runoff? He has given actually the area, volume. Both he has given. Where is the area? Area. Volume he has given, area he has given. This volume by area will give you basically this runoff. What is the volume? 2.25 hectare meters. 1 hectare is equal to how much actually? 10 to the power of 4 meters square. So that is how 2.25 into 10 to the power of 4 divided by 45 into 10 to the power of 4. So 10 to the power of 10 to the power of 4 cancels. So 2.25 by 45, it is 0.05 meters. So naturally we express runoff as in terms of centimeters, it is 5 centimeters. So what is W index? Total rainfall minus total runoff, total duration, if anything is there, initial losses. So if I have put total rainfall is how much? 9.25. What is the total runoff? 5. Initial losses 0. Total duration is how much? 6. So therefore your answer is this. So W index is always straight. So absolutely there is no problem. Naturally you also should remember now, once W index is obtained, the phi index value, will it be greater or will it be lesser? The phi index will be always greater than W index. Phi index is always greater than W index. Please remember that also. Now let us consider, now trial and error only you have to do it. What I will do, which is a value which is greater than this. So which is greater than this, I have taken it as 0.80 centimeters per hour. Now what I have done, put that 0.80 here, right? Now what is the effective rainfall? So when I put 0.80, you understood? 0.80. Is there any value in this which is less than 0.80? This is less, this is less, this is less. So that I removed it actually. So this is I removed main, because this is 0 time, this is lost. So main 0 values no need. So this is the main thing. So if I remove that actually, so 9.25 minus 0.5. So what it will be happening actually, you tell me. 9.25 minus one more is also here, 2 culprit actually. 2, 9.25 minus 0.5 minus 0.5. So how much it will be? It is 8.25. 0.5 plus 0.5 is equal to 1. 9.25 minus 1 is equal to 8.5. Why we are not considering this? Your phi index value you have already assumed as 0.80, right? So that I have put in. Then what is runoff? Actually already we got runoff is there. Now what is the duration? 1, 2, 3, 4. That is the only duration, because this is not considered, this is not considered. So that's why total duration is how many hours? 4 hours. Then R is equal to how much we got it? 5.05. When R is equal to 5.05, how it is acceptable? Because your original value of R is how much? 5 centimeters. So this is not correct. Now what I need to do? Another trial I will take it. How another trial I am taking? A little bit higher value. A little bit higher value if I take it and then do it 8.25 minus R by 4. Then in that case I got it 5.03. So like that you need to do. Probably my 0.807 if you put it, you may be very closer to 5.01. Like that 1 or 2 trials if you can make it and clear answer you can give it, that is fine. So this answer you can take it provided because this is closer to it. Or otherwise my sincere appeal to you is why don't you try 0.807, right? If it is sufficient, fine, or 0.8075. I am sure at this you can close your things. One more problem I will show you. A watershed of 50 km square produces a runoff of 0.2 million meter cube from the rainfall pattern of the storm shown below. Calculate the phi index. Time versus rainfall is given like last problem only. Again here also area is given, volume is given. So runoff depth you can calculate. By 10 to the power of 6, it is million to meter cube. Then it is what is this is because kilometer square. Kilometer square means 1000 into 1000. This is actually million. So that's why you got it as 4 mm. So now what is the thing? Trial value of this means W index. What is the total? All total put together from here to here you add it up. This is 18.3 already done. Right? 18.3 minus 4. Right? What is 4? Runoff. Divided by what is the total duration actually? 14 hours. That I put it. So this is what we got it. This value is W index. Naturally your phi index will be more than this or less than this, will be more than that. So when assuming more than that, I have assumed 1.5 mm per hour. So if I assume 1.5 mm per hour, then I have put 1.5 is equal to phi index. Then shall I put 18.3 here? Because total rainfall you told 18.3? No. Why no? Because you assumed it as 1.5. So this is less than 1.5. This is also less than 1.5. So if both are less than 1.5, so naturally remove those two. 1 plus 1.1, 2.1. So 18.3 minus 2.1, that is value is 16.2. So 18.1, 3 minus 1.1 minus 1 is equal to 16.2. So that is how it is. Minus R divided by how many hours? 2 hours, 4 hours, basically to see how many hours it has taken. This. So if I take it, how many things actually duration? 4 to 6, 6 to 8, 8 to 10. That's all. 10 to 12, no. Because if I consider it as this, I consider 0 to 2. This is I consider 2 to 4. This is I consider 4 to 6. This is I consider 6 to 8. This is 8 to 10. This is 10 to 12, like that. If I take it actually, in that case, it is 2 hours. This is 2 hours. Basically, if you are getting 2 hours, 2 hours, then total how much it should get actually, you should get how many hours totally. So it is, this is 1 2 hours, this is 1 2 hours, 1 2 hours, 2 hours. So total should be 8 here. Then you calculate what is R is equal to. Please check the answer once again. Then afterwards, you take a little bit higher value. If you take a little bit higher value, so we have taken 1.75. If I take 1.75 also, is there any change that is observed actually in these values? Actually, one point here, one small important point I want to tell you. So, because this is what while doing the problem, you need to think once again. So, remember that actually. Here what is phi index actually? 1.5 mm. 1.5 mm per hour. If it is 1.5 mm per hour, for 2 hours, how much it should be? If it is per hour, 1.5 per hour, 1.5 mm per 2 hours, how much? That means 3 mm. So this is gone, this is gone, this is also gone. So remaining is how much actually? It is only 6. This is right. That is where you need to slowly stop, because this is only a deceiving thing. They have given 2 hours duration. Previous problem is 1 hour duration only. But now how much he has given? 2 hours duration. So that is why I just took it and again I am cautioning you, right? So this is the first thing. So it is always phi index is per hour. For now time period is here, how much it is? 2 hours. So per 2 hours you should take it. So 3, that is also 0. So remaining hours is how much? 2, 2, 2. That is 6. It is correct. Right. Next, if I assume 1.75, then in that case, what is the thing? Per hour, it is 1.75. Then per 2 hours, actually, it is 3.5. So less than 3.5, how many? Anything is there? 1.75 into 1 plus 1.75. Almost it is 3.5. Anything is there? This is also gone, actually. Right? These two are also gone. Here even it is not 4 or 6 also. Here it is 4 only, gentlemen. 1.1 is gone, 2.2 is gone, 3 is gone, 1 is gone. So only thing is remaining is how much? It is only 4 only. So that is why if I take it now, only if I take 3.5, all are gone, only remaining is these two, 6 and 5. So that is why it is 4 hours. Why these 4 are gone? Don't unnecessarily confuse with phi index 1.5 mm per hour. But here durations you see, that is 2 hours duration. That is why 1, 2, 3, 4 are gone. Only these 2 are remaining. So effective duration is 4. This is 11 actually. Understood? So that is how we calculate. So this I have done in another fashion also. You can see it. What is the total rainfall? 18.3. Total runoff, just now I showed. Another way of solving. So first trial value 1.5 mm per hour. How trial value got it? W index is your trial value. Then I have put the time clearly 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12. Right? This is the rainfall. So if this rainfall is how many hours? This rainfall is how many hours? This is for 2 hours. If I want to calculate per hour, then 1.1 by 2, 0.5, 2.2 by 2, 1.1, 6 by 2, 3, 5 by 2, 2.5, 3 by 2, 1.5, 1. So what I have done, I have calculated intensities. Intensity means how much it is? Mm per hour. Now phi index also what I have assumed? 1.5. If phi index is 1.5, is there any excess here? Because this is 0.55. Phi index how much I told? 1.5. So excess is 0. Here it is 1.1. Phi index is 1.5. Excess is 0. Here it is 3. This is 1.5. So what is the excess? Actually 3 minus 1.5. So how much it is the excess actually? It is 1.5. And here 2.5 minus 1. Excess is how much? 1. And remaining periods, no, it is no excess, no excess. So here this 1.5 is per excess is for how many hours? 1 hour. Now what is the interval I have taken? 2 hours. So for 2 hours how much? 3 centimeters excess. For 2 hours how much? 2 centimeters. Total rainfall excess is equal to how much? 5 centimeters. 5 centimeters. Right? But what is your total runoff is equal to whatever you calculate is 4 mm. So if it is 5 mm, whether your answer is right or wrong? Answer is wrong. What I have taken now? 1.75. If I do 1.75 and do it instead of 1.5, now I have taken 1.75. If I take 1.75, here it is 0, here it is 0, right? And here also it is 0, 1.75. Anything is there? 1.75 mm per hour. If I put it basically, so 3.5, 3 minus 1.75. So how much it will be actually? It will be 1.25. 3 minus 1, 2.5 minus 1.75. It is 0.75. In that case, it is 1.25 into 2. And this is 0.75 into 2. 1.2 into 2, 2.5. This is 1.5. Total how much it is? 4. So what is your runoff? 4. So runoff is equal to rainfall excess. That is your phi index value is right. What is phi index actually? Whatever you have assumed, 1.75 mm per hour is correct. So anyway, whichever method you are feeling easy, you can follow. Another problem: a storm with precipitation produced a direct runoff of 5.8 centimeters. The time distribution of the storm are given below. Estimate the phi index of the storm. So time from the start, then the increments are rainfall in each hour. In each hour we have taken. So the rain from the start, 1 hour, after 2 hours, after 3 hours, after 4 hours, after 5 hours, after 6, after 7, after 8. So these are the values. So total rainfall is how much? Add all these things. This is 10. What is the runoff he has given? 8. So naturally W index value means 5 minus 0.8 divided by what is the total duration? 8. This is. So that is okay. Then phi index will be always greater than W index. Hence assuming phi index as a little bit greater than this 0.55. 0.55 is assumed. This is gone. This is gone. The remaining is how much? 1, 2, 3, 4, 5, 6. So 6 hours is the effective duration. On 0.9 plus 1.5 plus 2.3 plus 1.8 plus 1.6 basically plus 1. This is equal to how much? 9.1. So this is removed, this is removed. So if I put like that, I got 5.5 centimeters per hour. What is your runoff actually? 5.8. Still a little bit difference is there. Then runoff is equal to 5.5 centimeters, which is exactly correct. I cannot write like that. It is almost nearer to that. And if you want to make a trial again in this also, you can do. Rather than 0.55, 0.555 you can make it. 0.555 or 0.558 if you put it, probably you will reach to this as 5.8. You can check it out. Compute the infiltration index phi for the following data. Total rainfall duration of the storm is this much. Estimated groundwater contribution in the total runoff is equal to this much. Area of the basin 250 kilometers square. So now I have given the time durations, each intervals. Now I have given intensities only, right? Compute the infiltration index phi. Total rainfall values are total rainfall during the storm is given. Estimated groundwater is given. Area of the basin is given. So what is the total rainfall? Volume divided by area. I got this. Any doubt here? Please tell me. 76.25 into 10 to the power of 6, whatever he has given. 250 kilometer square converted into meter square. Hence only groundwater contribution in total runoff. This is the groundwater contribution. So this equivalent to how much depth? By area, this much depth. So now runoff is equal to what? That rainfall minus infiltration. So storm duration is not given. Storm duration is not given, but 16 hours. We assume total duration. Phi index is equal to rainfall minus runoff by storm duration. So 30.5 minus 30 by 16. This is it right value actually? Right? Tell me, is it right? Phi index, can you assume like that only? 30.5 minus 30 by 16. That is the storm duration he has given. 0.3125. So what it actually corresponds to? Anybody tell me what it corresponds to? It corresponds to W index. It corresponds to what? W index. Now what you need to do it is, your phi index value should be a little bit greater than this value. This is not phi index actually. This is W index. And phi index is greater than W index. So now what you need to do? Take a trial value. Suppose for example, you can take it 0.35 mm per hour. Right? Because problem why I stopped at this stage is there is something wrong in the data actually. That's why I stopped here. The reason being that if I take 0.35 mm per hour, all the things if you see, their values are 12.5, 15, 20, 20. But what we are assuming is how much actually here. So that's why the duration of the storm is missing. So that is why I have to assume total duration. Because of that, the answer is getting actually an unreliable value of this. So I did not extend this problem. The reason is that whatever value you assume also, it always will be basically, you can see that every time it is less than whatever is thing. So automatically everything is contributing. So finally you land up only with this. So that is why the reason might be he has not given what is the exact storm duration. If that should have been given, the problem should have been very simple. A catchment area of 40 km square has one recording rain gauge. During the storm, the following mass curve of rainfall was recorded. If the volume of rain runoff due to the storm measured is this much, estimate the phi index. Time from the start he has given. Accumulated rainfall, exactly this is the right thing. People should do it. Accumulated rainfall. So it is initially 2. After 2 hours, 8. After 4 hours, 22. That means between 2 to 4 hours, how much? 22 minus 8. Between 4 to 6 hours, how much? 74 minus 22. Between 6 to 8 hours, 92 minus 74. Between 8 to 10 hours, 105 minus 92. Between 10 to 12 hours, 114 minus 105. 12 to 14 hours, like that you should, because this is accumulated one. Now, what is runoff depth? Runoff volume divided by area of catchment. Standard thing. So, which we have calculated. Total rainfall, how much already? I got it as 120. Don't sum it up. It is already summed thing. Accumulated means already summed up. So, that's why accumulated, general rainfall or rainfall per hour. These are the words which you should really know. So, rainfall mm per hour, if it is given, you need to convert into depth units. If it is given, for example, in mm, you should add the total. If it is given accumulated runoff, the final value is already accumulated value only, summed up value only. Total losses, so that means 120 minus 50, 70 mm. So what is the duration of the storm? 14 hours. So P minus R by total duration, 70 by 14, 5 mm per hour. That is fine. Now phi index will be greater than W index. As per W index, the infiltration loss for every 2 hours is how much? So now infiltration loss is how much, which we have projected actually. Infiltration loss means W index. W index is 5 mm per hour. But here time duration, how much he has given? For every 2 hours. So per hour, if it is 5 mm, for 2 hours, how much it is? For 2 hours, it is how much? 2 into 5, it is 10 mm. So that's what it is. Now find the rainfall in each duration from the accumulated rainfall. Now this is the accumulated rainfall, which is, this is given, this is given. Now I have found out what is the rainfall in each duration. This is in mm. This is also mm. This is hours. So initial, okay. Now 8. 22 minus 8, 14. 74 minus 22. See this? Over. Now infiltration loss is greater than rainfall in time durations. So infiltration loss, how much I told? For infiltration loss means W index for 2 hours is how much actually? 10 mm. In this hour it is less than any hour actually. In this hour also it is less, right? For say to first 2 hours, then 12 to 14 hours it is less. Remaining runoff means 1, 2, 3, 4, 5. 5 durations. Each time is how much? 2 hours. So 10 hours basically. Is it right? Or here also gone because it is 10. So this is not there. This is not there. This is not there. So 3 gone. So remaining time durations are how many actually? This is 1, 2, 3, 4. Each of 2 hours. So that is why it is 8. So now add these 4 only. 14 plus 52 plus 18 plus 13. This is not counted. Why? Because this is less than infiltration. This is not counted. Why? Because this is less than infiltration. This is not counted. Why? This is less than infiltration. And what is that infiltration? W index. W index is 5 mm per hour only. But why 6 is removed? Because per hour it is 5. For 2 hours, how much it is? 5 into 2, 10 mm. So that's how I did it. So remaining 4 I have put it, 50 I have put it, 5.8 mm per hour I got the answer. Very trickish questions. So now I will stop this lecture at this phase and I will continue this lecture also with one or two problems after this. Let us see it. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.